designed an electronic computer for solving systems of linear equations, but it never really worked properly. But you see, despite all the the hurdles that may have come through in development of such kind of devices, the developments never really stopped happening. And particularly ENIAC was developed, and then ENIAC actually dealt with dealing with numbers in a decimal manner, and then further developments included development of EDVAC. So if you can see, this is two pieces of ENIAC currently displayed at Moore School of Engineering and Applied Science. So as you can see from its size that it's a huge size, and ENIAC stands for Electronic Numerical Integrator and Computer, whereas EDVAC, it was more like a discrete variable automatic computer. So you see the developments from differential engine, which was powered by steam engine, came the analytical engine, and then after during the wartime, these kind of devices were developed. So the development never really stopped. What do you think that what do you think is the reason that people didn't really stop at a particular prototype of a computer during that time? What may have led to the continuous improvement? What is the reason according to you?
They wanted faster, more efficient, that takes less power.
Okay, so they wanted to be better at it. Someone raised hands. I think Sai Krishna, you wanted to say something.
Yes, ma'am. So as time went on, needs also started increasing, and the existing computers were not sufficient. So they need to build better and better systems for taking care of their computational needs.
So for a moment, just imagine, we're talking about the 1940s. What, how developed technology was during at that time? What may have led to, great challenges to these people? And in the face of such challenges, what may have led to their persistence in attempting to solve this kind of problem?
Ma'am, I'm pretty sure the biggest example would be World War One and World War Two, where they needed to calculate where the missiles would land and how many they have to produce and stuff like that. And probably also because at that time, I think Britain was like ruling a large portion of the world, so it needed to keep track of what places it was taking care of, how many people were there, like how much money was flowing and all. So so I think computers were like faster and better computers would have enabled them to do easier job, would have enabled their tasks to become easier.
Okay. Yes, that's right, Sai Krishna. I think the importance of the task and significance of tasks at hand may have fueled people to continue working on it. And as Aditya and Advait have also mentioned that faster and to be able to multitask things, and you need to be better than your enemy. So that led to the persistence. But it's one thing to look back at history, see what they have done, and admire it and appreciate it. But it's really an altogether a different story to be in their shoes and actually appreciate and apprehend the very real challenges that they may have faced while dealing with things. And not to say, obviously there would have been moments of frustration or despair and disappointment, but also times when something would have worked fine. So innovation is a process. Obviously, when the process is executed in a systematic, organized, and critical manner, it leads to output. But innovation, in a sense, is a process, and because it is a process, this process has never really stopped. So computers continue to get evolved over the period of time. Now, another interesting thing that emerges during the same time is the invention of transistors in the 1947. And that transformed the computers completely. Now, why do you think that the invention of transistors had such a significant impact on how computers were created during that time? Advait.
Ma'am, the transistor was like significantly smaller in size, and its features allowed for better functionality as well. I think the predecessor of the transistor was the vacuum tubes. I'm not too sure about that, but this allowed for a huge step forward as we were able to do faster tasks, and we were able to make the computers more compact as well.
Okay. Thank you, Advait. Sai Krishna.
Yeah, before the transistors, there were probably like mechanical switches and all for our operations. So manually switching it on and off or to our desired values would have been like harder. But transistors with passing electricity or not passing electricity, we can perform two operations at an incredible speed, and we could do it repeatedly. So, like if, for example, if I'm repeatedly switching on and off a switch, it might get damaged, but a transistor is not going to get damaged by repeatedly turning on and turning off the current.
Okay, Priyansh, Deep, go on.
Ma'am, as the circuit was too large and such that the circuit was transferred into a smaller transistor, like they were very large circuit, and then and on this transistor, their circuit can be compacted, and hence the use was more compact, and space was saved, and many things like Sai Krishna mentioned.
Okay, so a large scale design sort of was, transported to a small scale using transistors. Deep, what do you have to add here?
Ma'am, actually, transistor was invented because of small size radio. I have just watched the history of transistor because of then the necessity of NASA, because after all, when there is a war between America and Russia to innovation, that lead to NASA to launch the rocket uh, in a moon. For that, they want a small computer which handle large tasks. And at that time, when we use tubes, it was not efficient. It's around weight of 2 or 3 tons, and there is barely power of the rocket to launch such a huge weight. That's why the transistor come on. They are very small in size, consume very less power, more efficient, and bear lots of heat, whereas mercury just spill out, and it may be dangerous for pilots. That's why it lead to invention and processes innovation in transistor.
Okay, thank you, Deep, for that wonderful explanation behind how transistors came into picture and how they absolutely revolutionized our society. Pratmesh, yeah.
Yes. Earlier, we used to have these vacuum tubes in the computers, right? So the transistors were, I think, invented to, make the size more compact, and also, use less power, because earlier vacuum tubes were consuming very high amount of power.
Okay, Watson, thank you, Pratmesh.
Ma'am, actually the transistors, they they switch matlab, they make the process very efficient and make the process very fast. And also the, as already mentioned, it makes the size of the computer compact and make it work more efficiently.
So, how many of you have actually seen any samples of transistor? So, where have you seen it? Where have you seen it? Any example?
I've seen transistors in my school when there was
Code
electronics
radios.
lab. I I just
Yes,
worked
ma'am.
on transistors.
I mean,
Ma'am, I
lab.
was preparing for Tesla coil, then I come to know about 2N, 2N transistor, and many more other transistor for that process, and resistance also.
So, I hope you know the difference between the NPN and the PNP transistors. It must have been in your 12th class syllabus.
Yes, ma'am. Yes.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Okay, great. So, the invention of transistors, helped in improvement of the development of the computers. Siddharth, do you want to add something?
No, ma'am.
Okay. I see raised hands. Amog. Okay. So, and for that, they also won, Nobel Prize in Physics. The important thing again is, see, there were a set of people who were already working on, trying to improve the way computers could be created and designed. And then there's this invention that comes up that further accelerates the development and the quality of computers that are formed. So I think in one of the classes, one student had asked what is the meaning of interdisciplinary. So this is exactly what interdisciplinary means. Developments in one sector, impacting the development of the sector, and then, sort of coming together to improve the overall product or service. So computer development did not really happen in isolation. Lots of, political things were impacting it, social things were impacting it, and then developments in technology were impacting it. So you see this entire ecosystem that may have led to the development of, computers and their functionalities, and that holds true even in today's world. So this is one of the, machines showing, EDSAC, which is electronic delay storage automatic calculator, and the difference between ENIAC, EDVAC, and EDSAC are actually apparent in their full forms also. So basically, ENIAC was primarily designed to, calculate certain statistics during the wartime and to study the feasibility of thermonuclear bombs. But it was, however, decimal based. EDVAC, on the other hand, was binary based, and EDSAC was built according to von Neumann machine principles, which we'll be discussing. But the main question arises over here is that what may have led to the, the change from a decimal based system to a binary based system?
Ma'am, a binary based system would be easy to understand, as when we work on binary digits, it is easy to decode a message or anything that is forwarded to us.
So easy for whom?
And for suppose
Computer.
that at that yes ma'am, at that time war was taking place, we were in that situation that we would have to ease our work. There was so crisis that we would have to just make the computers more efficient,
Okay.
so that they can easily understand what secret messages were exchanged.
Okay. Thank you, Akhand. Priyansh?
Ma'am, at that by using binary, we are only giving computer like two values to deal with, and by using decimal system, they will making multiple value to deal in from the perspective of computer. It's like they are only using two values like true or false, so that all the data can be arranged in the form of those two values, so that it is easy to interpreted by the computer.
Okay. Thank you, Priyansh. Vatsal?
Basically, if we put the values in some other form, so the computer has to scan through the each and every value and need to understand what is given in that value. But using this system, only 1 and 0 are provided, so the computer can interpret it in a better way. And moreover, during the wartime, it was easier to communicate. It was means safer to communicate using the 1 and 0 system.
Okay. Thank you, Vatsal. Siddhant?
Ma'am, like humans, ma'am, they were already able to do the small calculations. What they wanted is to make the bigger calculations, and for the bigger calculations, ma'am, basically we used binary, because binary, like if we have 10 places, if we use the normal number system, we can just write a 10-digit number. But if we use a binary, we can write 2 to the power 10 numbers with the help of that 10 places. So it gives us the power to calculate huge values, and that was I think the main reason why binary was introduced.
Okay. Thank you, Siddhant. Siddharth? Rodrigues?
Yeah, ma'am. Because binary was really simple to represent on a computer. If the power is there is some power, then it is 1. If there is no, current, then it is 0.
Yeah. Okay. Thank you, Siddharth. Atharv?
Yes, ma'am. My answer is also same like Siddharth, like on and off. 1 and 0 represent that, and that is easy.
Okay. Harsh?
Good morning, ma'am. Ma'am, binary is introduced because the binary is only way to communicate with the computer, on and off. Still now we can't use any other form to communicate with the computers other than binary. Even now we are trying to make supercomputers that are not based on binary, but still we are unable to produce them. So the binary is the only system, or we can say algorithms that we can communicate with the computer. That's why they are introduced.
Okay. Thank you, Harsh. Thank you, everyone. Aditya, yes, go on.
Ma'am, just because Harsh raised the point of supercomputers, ma'am, actually one supercomputer has been developed
which can represent 1 and 0 at the same time.
Okay.
That's it, ma'am.
Okay. And Prabal mentions to save memory, binary systems were used. Would you want to explain it, or anyone who wants to counter?
No,
what-
ma'am. Binary uses more digits. Let's say number 8 in our normal computer uses 8 byte or 1 bit. But if we write number 8 as it is on our, let's say, notebook, we write number 8 as we write in numeration. So actually binary uses more space than any other thing.
So thank you for the interesting discussion. I think it is important to study about at least how the binary system was developed. In fact, Leibniz had proposed it quite earlier, but it was much later that actually George Boole, made it much more practical to use binary system in computers. If I get some research, I will share it on your recommended reading in the classroom, because it's a logical question. People were dealing with decimals, numbers, and then suddenly, there could have been many alternatives: binary, unary, trinary. But why only binary was selected? So, the reason behind it is important because it helps us to understand the perspective on how the decisions were made, and it is very important to also sort of realize that computers were starting to act on binary systems, and we are in 2021 and the system still remains unchallenged. So think about the extent of thought process that may have gone into development of this binary system, which we really do not even think about in modern times when we are dealing with computer, because computer is everything is happening in ones and zeros. But for a moment we must pause and try to understand the quality of thought process that would have happened, that in today's time, even now, it remains unchallenged. Whereas EDSAC was built according to von Neumann machine principles. Anyone who has heard of von Neumann machine principles before? Okay, so this is a small diagrammatic representation of the von Neumann machine. So each modern computer has the same 5 basic components: memory, control unit, arithmetic logical unit, input and output. So this prototype has been named after the scientist who proposed and designed it. So this design has been influential in the design and evolution of modern computers. So as you can see that the arithmetical logical unit is the main thing that computes or does the calculations. The accumulator. So what's the difference between accumulator and memory? Any hints?
Accumulator might be the RAM and memory might be the storage.
But RAM is also a type of memory. So RAM and ROM are always memory. What is an accumulator?
Ma'am, accumulator is a very small amount of memory that is used for temporary storage of variables on whom arithmetic operations are being performed.
Yeah, thank you, Aditya. So it's sometimes we need to store the intermediate states. If multiple calculations are happening, we need some place wherein we can store some intermediate output, and that is where accumulator is used. So for example, if you want to add 2 numbers and store it in C, so A is one number, B is another number, and C is where the output is stored, and there are multiple calculations depending upon these values. So basically accessing memory again and again can be time consuming. So that is why accumulator sometimes is used to store intermediate values so that it can be accessed much faster. So yes, Sai Krishna.
Isn't that essentially what RAM also does? I'm not sure I understand the difference between accumulator and
Actually, RAM is accumulator is not a part of memory. RAM is still a random access memory, so it's still a part of the memory. Accumulator, although there is some analogy between that, but accumulator generally is not called as a memory. Okay.
Okay, yes, ma'am. Thank you.
It is at the same time it's important to understand the difference between memory, accumulator, and registers. Anyone heard of the term registers before in the context of computers? So
Yes, ma'am. Yes, sir. Yes.
Yes, ma'am.
What is a register?
It stores one variable.
So how is it different from a memory?
It works on the 8085 computer model.
Okay, so see, basically register also helps us to understand, there are registers which are, separate from the memory, although they have some amount of memory, but they help us with intermediate calculations and when we need to access the data again and again. So it would be nice to read more on the difference between, sometimes it gets confusing between accumulator and RAM, but RAM is still, a kind of memory, whereas accumulator generally would not be falling under the realm of a memory. The transition from analog to digital, we have already studied. The advent of World War II prompted this transition. Moving on, this is a small image that shows, the ENIAC machine in the bottom left, and the Colossus, which was designed by Alan Turing, and the vacuum tubes. In which standard did you read about vacuum tubes? How many of you have seen televisions based on vacuum tubes?
CRT kind of.
Cathode ray tubes, you mean? Yeah. Okay, so in 1950s, I think the development of computers began much at a rapid pace. Compilers were invented by Grace Murray Hopper, and I'm not sure if you are being taught compilers in computer programming, at least a hint of it. Anyone knows what is a compiler?
It
Yes, ma'am.
makes the code that we typed readable by the machine.
Okay, and any language that you know which doesn't need any compilers?
When Python needs interpreter.
HTML.
Yes, Java and Python need interpreter.
Yeah.
Okay, so anyone who for their friends wants to explain the difference between an interpreter and compiler?
Ma'am, interpreter converts into machine language line by line, and compiler does it in one go.
Okay.
And compiler generally converts the code directly from machine language to from high level language to machine language, but an interpreter first converts that machine code, that high level language code into binary code, byte code. Then it
Byte code.
converts it into machine level code.
That's right. That's right.
Ma'am, compiler is platform dependent and interpreter is platform independent.
Okay, so for compiler, I think if you code, compiler actually helps us to create an executable file, finally, which is actually run when the computer program is run. So, these days, modern editors have, inbuilt compilers, but, earlier, I think during our time, sometimes when we were in college, we used to write the code and, sort of compile it in the command line prompt. And then actually a compiled file, an executable file would get formed, and then we would run it again to run the computer. So this is basically what the compiler used to do. I think we have already talked about Alan Turing's Turing machine, but there is something called as he introduced Turing test. And Turing test basically was another milestone in the development of computers, which actually, diminished the boundaries between a human being and a computer by showing, it was sort of an experiment in which, suppose there is a room, there are two rooms. In one room there is a computer, in another room there's a human being, and then there is a third human being who is interacting with both the computer and the person, obviously at a separate time. But if he or she cannot distinguish between who is a computer and who is a human being, what would that mean? If you are dealing with an external party and, at the end of the conversation or at the end of interaction, you are asked to answer the question, who do you think was the machine, who do you think was the human? And if you are able to do so, or if you're not able to do so, what would that mean? What would be the implication of that thing? Any hints?
The computer has passed the Turing test.
Yeah, so when the computer passes the Turing test, what would that mean? What would be the implication of that? That our computer is developed enough to
Communicate and
Well, as a human
Act
being,
like humans.
communicate as
like
well.
humans.
Think
yeah,
by itself.
it's actually become a more sophisticated type of thinking machine. So I'll show you a very small video of Turing test. I hope the screen is visible to you.
Yes, ma'am.
Yes, ma'am.
The Turing test, created by pioneering computer scientist Alan Turing, comes up a lot in sci-fi culture and discussions about intelligent robots. But what exactly is the Turing test, and what does it mean if a computer passes it? Alan Turing first described what we call the Turing test in a 1950 paper. Turing wanted to answer the question, can machines think? To get to the bottom of this, he devised a hypothetical test. Imagine a game with 3 players. One player, the interrogator, is isolated from the other 2 players, one of whom is human and one of whom is a computer. The interrogator's job is to try and figure out which is the human and which is the computer by asking questions of both. To make things harder, the computer is trying to make the interrogator guess wrongly. In other words, it's trying to be as indistinguishable from a human as possible. If, more often than not, the interrogator is unable to determine computer from human, then hey, maybe we're dealing with a thinking computer. Attempts to build computers that can fool humans have revealed some fascinating challenges. For instance, it's hard to make a computer that's good at telling jokes. The Turing test isn't a perfect test of robot intelligence. For example, it encourages trickery. One recent attempt involved a program pretending to be a young boy for whom English wasn't a first language, conveniently covering up any linguistic slips. The Turing test also doesn't account for non-human intelligence. Some of the smartest computers around today have no chance of pretending to be a person, but that doesn't make the advances in AI that they represent any less impressive. So just because a computer looks like it's passed the Turing test doesn't mean we have to bow down to our robot overlords just yet. But nevertheless, Turing's experiment gives us plenty to think about in terms of how we define intelligent behavior and what we would want from an intelligent robot. And after all, who doesn't like thinking about robots?
Okay, so that was a bit about Turing machine. I'm not sure how many of you have watched the movie Matrix.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, so do you see any, so what exactly is happening in the movie Matrix? What is the analogy between a thinking machine and what exactly do you see over there?
Computer simulation.
I would request you to elaborate on that. So computer is simulating what in that movie?
That all the peoples are made up of codes and programs, and their reality or destiny is fixed by another person, by another post-human civilization. That they show all these metrics were made by peoples that were more superior than others.
Okay, thank you, Siddhesh. So for those, yes, Priyansh.
Ma'am, so the basic story was that when the human made the AI, then the AI needed the power source, and then some humans decided that they need to cover the cloud by the dark cloud so that solar power can't reach on the earth. So that AI decided to use human as a power source. So using human as a power source, they decided to put them in a simulation so that their mind is engaged. They are not disturbing like.
Okay, Priyansh, that's a very different perspective. Thank you for sharing that with us. Utkarsh, you want to add something?
Yeah, the computer is basically simulating human consciousness.
Okay. Yeah.
That's it.
And what do you think about it? What do you think about it? To what extent does that look feasible to you or true to you?
I mean, if the world is continuing as it would have been in reality, then it means that computer have simulated human consciousness quite accurately. And
Okay. Or a
I mean,
computer has simulated human conscious quite accurately, or human consciousness is nothing but a predefined, thing which is already been simulated.
When
And
we
yeah,
when we say that our fate is pre-written and we are the puppets of God, who knows these programmers are the God who had already pre-written our code, and we are on what we do in our day-to-day life is just a simulation of these programs.
could be. So there's always a debate between free will and destiny. So again, Matrix clearly points out to that. Ghanshyam?
Consciousness of being existing and freedom of choice.
Freedom choice,
I
yes.
mean, in movie they created their world exactly like human world, but they were not real. They were computers and codes.
Maybe that was the human world, and maybe Matrix was trying to show some bits of reality.
That is the hypothesis right now. Are we in a computer simulation or not?
Okay, okay. Thank you, Ghanshyam. Sai Krishna, Siddhant?
Ma'am, so we may not be in a computer simulation actually. So because let's say some civilization builds a computer simulation and simulates a bunch of humans, simulates a society, and then that society becomes advanced and then creates a society in itself. So that chain continues. But when we look at our human civilization as of now, we don't have the technological prowess or the computing power to simulate another reality. So that means we are either the first real civilization, or we're at the end of this chain. So like with the huge chain, the probability of us being a simulation is actually very less compared to us being the real and only world.
Okay, so I'm guessing you would have watched
Neil deGrasse Tyson's
Matrix movie still when you were in school. Okay, I have watched Matrix at different points in my life, and what I have taken back from that movie is completely different, even contradictory to what I used to believe before. So Utkarsh and Siddhant, what do you have to add?
Ma'am, I think that we might be in a computer simulation because, ma'am, if we think broadly, like what actually is like what we do today, we do coding and we give input and we get an output, right? We write a certain algorithm and we get the output. But what we can connect is with our brain. There is a certain part, we should not go into the biology part, the cerebrum and the all. It gets the neural information to the neurons and all, and it gives the output. But as of now, we humans are not able to decode that algorithm which our brain gets. So the day which we like decode that algorithm, that is surely very much complex. So if we decode that algorithm, that day we will be able to ourselves make a brain which can work like a human. And if anyone else who have decoded that algorithm, then we might be under them. I think that.
So here is that one addition of my own limited thinking to your point. Every person may be able to decode that algorithm for their own self. Ultimately, if we believe that we live in a simulated environment. Khemendra.
Yes, ma'am. I'm against this computer simulation because things which we don't know, we used to make conspiracy theories and make things interesting. If we are in computer simulation, then अपन उसका क्या कर लेंगे? It's already programmed, each and everything.
Okay, so for those who have actually not watched Matrix, let me provide a brief background. So this, and I absolutely strongly recommend you to watch that movie, Matrix. It is actually a trilogy, but you start from the Matrix Part 1. And you know,
Ma'am, fourth part आ गया है.
fourth part, it's about to come, I think.
25th December
already
को आ
got
गया,
released.
ma'am.
December को आ गया, ma'am.
Yeah,
देखिए,
ma'am,
ma'am.
that actually explains the computer simulation bit a bit more because, I mean, without spoilers, you cannot talk about it, but that actually explains the simulation part a bit more.
Okay. So just to give a background to those who are not familiar, the movie talks about that all of us live in a sort of a matrix, which is already pre-programmed, and humans are nothing but, you know, simulated bodies which are actually doing something which they are being told to do in some or other manner. And there is a system that wants humans to remain a part of matrix unless some people, as Khemendra points out, have decoded it and, you know, belong to a, I think, Zion, that kind of party. So I strongly recommend you to watch the Matrix movie because it weaves together two very important things: computer programming, human thinking, and human consciousness. Going on to Osaf Ali. Osaf, you want to say something?
Yes, ma'am. So I am actually against this idea of simulation because recently there have been these two scientists. I don't exactly remember their names, but they ran complex mathematics on some quantum objects moving through multiple dimensions. Basically, the summary of that was that there is no mathematics that is able to simulate our world. So that way they were able to say that since we can't reach that point of simulating any world, so there, we must not be the simulation.
So I think obviously humans always aspire to decode complex natural algorithms, okay? And just because science is not able to explain that may not always mean that there is no structure to the things that happen around us. That is my take. Akash? Rathor? So I think we can go on and discussion about the movie Matrix and, you know, developing sort of analogy between our world and, you know, what the movie mentions. Nikhil has mentioned in the chat that if humans are programmed, then how those programmers originated. Are they also programmed by someone and go? So if humans are programmed, and we don't know about this, but it's nice to think programmers, not just Homo sapiens, but you know, just look at it in a much broader perspective. Priyansh?
Ma'am, I have two perspectives to add. One is like I watched a research paper that says that our reality is nothing but a world of probability. Like if you look at the subatomic levels, it is like we are the electrons is like a waves of the basic matter. In the matter, that atom in the electron, it's like the probability, like it exists or not exist. So if we are able to simulate that much into the subatomic level, how is it it basically just say that what we decide is what we get. So how can we be in a simulation if we are in a waves of probability? We are just a wave, like we are just existing as a wave, and we are just making in a probability, like in one world we exist, in other world we don't, like and other perspective is that it's one of my, I was thinking that if we make a simulation, like we make GTA games, like if we are playing GTA and character gets out of control, like the one who is running the simulation will automatically boot off the system. Like if you are playing a game, then character gets out of control, you don't like to play. So if there are some higher entities that are controlling us, then if we are getting control, if we get out of control, the system will automatically be booted off. Like it's my perspective. I don't know if that makes sense or not.
Okay, but thank you, Priyansh. When we have a discussion, it's important to recognize the fact that we never indulge in discussion to take sides between right and wrong, but to appreciate that, you know, all of us have a different thinking process, and through each other's thought process, our own horizons get broadened over that. Sankalp?
Ma'am, I wanted to point out, like, if anyone has watched the movie Free Guy, it's about a guy who is living in a game, but
Yes, ma'am.
Yes, ma'am. It was a recent movie.
It's the real world.
What about?
So maybe that's happening. We just think.
Okay, I think there is another movie, Hitchhiker's Guide to Galaxy. Hitchhiker's Guide to Galaxy, something like that. So that is again.
Is it Passengers?
A very good book.
I'm not sure. I've just heard of it, but it's based on the similar theme, I think, of the.
Yes, ma'am. I heard it too.
Okay, great. So thank you for that discussion, and I really recommend you. You know, it's not very regular of me to talk about movies in the class, but this particular movie really took me, you know, off my feet. And I think there is another movie in which I think a woman is able to perform 100% of her brain.
Lucy, ma'am.
Lucy. Yes, ma'am. That also, I think, you know, what happens is that when we are studying a subject such as computer science, getting to know about computer programming, you know, there are always limits but there are always potentials. And through fiction such as this helps us to gain a broader perspective on things like that. And talking about Turing test, a computer that can think, or humans, are they already programmed? In fact, yesterday I was in a conference in which a professor from Jadavpur University was actually giving a demonstration of his lab, in which using robotics, robots, and using cognitive neuroscience, he had actually identified the sections on the human brain which get activated when a person is angry or in love, in affection, and the two range of emotions, the high frequency emotions and the low frequency emotions. And he was able to detect on a human brain which portions get activated. So a natural question that arose was that what is the implication of being able to identify such regions in the brain? So that's one scientific achievement, that okay, we are able to identify it, but again always connected to the practicality of the things. And then obviously one of the students had asked this question, okay, what is the output? And then he had said that okay, that if we know that a particular human being is not really feeling well or nice, then maybe a higher frequency emotion can be injected. But that again goes a bit against what humans are. And I think one of the students had also mentioned that humans are not machines. So because you and all of us are sort of bearers of a new generation of thinking and technical computing, we always should also keep a look at the responsibility and ethics side that comes with the computer science discipline. And along with the technical things we will be discussing, I think we will also be discussing about the ethics part of it. But strongly recommended, do read about the movie Matrix if you're not able to watch it. So moving forward, and thank you for that discussion. In the 1960s, I think the developments of computers and computer science continued. The first science department was formed at Purdue University in 1962. So Purdue University's computer science department is quite old, and it's quite well known for its output of research as well. And then it was during this time that programming languages started getting invented, operating systems saw major advances during this time. And I'll not talk in detail about operating systems in this lecture because you have a separate subject of it, but I'll definitely provide some foundation knowledge of what operating system is. In the 1970s, again, with the coming of databases, the theory of databases saw major advances, as a result of which computers did actually improve in the way they were dealing with the storage of data and accessing all these kind of creation, reading, updating, and deletion of all this kind of information from the databases used in computers. During this time, it also saw the rise of supercomputer. One of the, this is a prototype of supercomputer crate that is actually shown at museums, as you have shown in the right hand side picture is at the Polytechnic Institute in Switzerland. So, just, you don't have to remember the names, but just to show you that people were consistent and taking steps one after the other because they were not satisfied. They were not satisfied with what they had created, and they wanted something which was user-friendly, easy, and actually being able to do what they wanted to do. Around the 1970s, so far we have talked about computers which are either in the laboratories or scientific institutions or organizations. There is no discussion on the home computers. Now, before we talk about the advent of home computers, what would have led to the thinking, okay, home computers are necessary? So they were in labs, they were in institutes, they were in companies, but what would have been the thinking behind this, okay, we need home computer? What do you think, which have triggered the recognition of the necessity of the home computers?
So that people could work from their homes and generate more money for the government and things.
Okay, but since people are already going to jobs and there is a computer over there, so they can do over the work over there. So what think deeper, what could have been the reason behind?
Computers can ease the task or day-to-day task of the people.
Okay.
And they can also do the things that the humans can't do, like lot of checks that they can process, and the many data of census and election and many other things that the large number of humans needed, but a single computer can do it
Okay.
with 100% accuracy.
Thank you. So far we have been talking about computers at an industrial scale or factory level scale. Yes, Ghanshyam.
Ma'am, at smaller scales, the contribution can be more contribution can be made. Like if in a supercomputer, 5 people are working, they will get lesser time. If they get one machine on their own, they can explore more, they can contribute more.
Okay. Sai Krishna. Thank you, Ghanshyam.
So home computers are probably much smaller and probably also portable, like when they were first invented. So like if we think about like the era, like 1970s and all, that was the time when archaeologists and all was like coming to Africa to excavate the Egypt pyramids or like going to some other places where computer technology did not exist. So Africa and like some of the Southeast Asian countries back then, where they came to do research and like note down numbers and statistics and then go back. So like it was hard to do it by hand, but if they had a portable computer, they could easily get the data and then send it and then maybe take it back. So like that could also be one that sparked the necessity for a smaller computer.
Okay. So do you think this could also be linked to the fact that people started realizing that okay, computers could be actually useful at a personal level also, in addition to the level of industries, companies, or factories?
I actually don't see how common people would recognize that need during 1970s because like I don't know what kind of tasks there were that they need computer. Like,
Okay. So here's an interesting perspective. Most of the times in entrepreneurship we talk about this. Sometimes people don't even know what they need unless you show them you need this, and that would have surged the entire market of personal computers and home computers. Kalash. Thank you, Shaikh.
Ma'am, people always wanted to live a cozy and comfortable life. So when they know that a new technology is coming, so they always thought that why can't we have that technology? So maybe that led to the development of home computers.
Okay. So thank you, Kalash. I think before we start talking about personal computers and home computers, this discussion was really important because before this we were talking about computers to do some kind of task like counting census or automating operations and things like that. But the entire field of home computers and personal computers are absolutely revolutionized the way people live actually their lives today, and so much so that even our phones are also smart and are like mini computers. So we will take forward this discussion on home computers and personal computers in our next class, and I will actually show you the market share of how different companies have come over this entire field of manufacturing and selling the whole computers, and how this revolution keeps on going. So I'll stop at this. I have seen so many comments in chat today, and I have not been able to individually respond to them, but I will go through them after the class, and I'll respond to them in the classroom. But your comments are really very significant for me, and I personally go through all the comments. So I'll go through them just to show you, just to see how you are thinking on different things that we are discussing. And then we'll carry forward a discussion on the home computers and personal computers. And after that, we will wind up the history of computer science and move on to other aspects of computer. So thank you so much for your time and a lovely discussion. Always happy to be in the class with you. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am.
Thank you.
Thank you, ma'am.